Hello and welcome to this DCD talk on commissioning power for AI scale. I'm Emma Strutton, I'm head of channels at DCD, and I'm delighted to be joined by Nick Funyak, who is the field services manager at Starline. So thanks so much for joining me today, Nick. How are you?
Good, Emma. How about yourself?
Yeah, very well. Thank you
Good.
for asking. So to start off, are you able to tell me a bit more about you and your career journey and your role at Starline?
Yeah. So my name's Nick Funyak. I'm with Starline. I'm the field service manager, like you mentioned. I've had quite a journey with Starline. I started there about 11 years ago as a drafter on their product engineering team. Did that for a bit. Finished with my school with my mechanical engineering degree and moved into an application engineering role. I really enjoyed that, working with the customers, designing some of the data center spaces and a lot of the modular type businesses. So did that for about 4 years or so, and then about 4 or 5 years ago, I moved over to the service side of things, and it's been a trip since then.
Fantastic. Sounds great. So, I suppose to get us kind of straight into the conversation, of course, AI workflows are driving a major shift towards higher capacity power distribution systems in data centers. So, what are the biggest changes you've seen in data center power architectures over the last couple of years?
Yeah, no, good question. So after the over the last few years, right, what we've seen a big jump in is, and I'm sure everybody's talking about it as well, is the increase in rack density. We went from doing 17 kW, 20 kW, 30 kW racks. Whereas some customers now we're seeing anywhere upwards of 50 kW all the way up to 150 kW, which is just a humongous jump, right? You're talking big connectors coming down into here now. You're in some situations we have some that are 150 amp and 200 amp connectors coming off of our bus. So really high density racks, high density tap offs with our plugins as well too, and a whole change in our busway as we knew it in the past.
Yeah, yeah, absolutely. And as operators move towards these higher density AI environments, how is the role of high power buzzway infrastructure evolving?
Yeah, so what we've been seeing lately is, when I started 11 years ago, we were seeing a lot of 400 amp busway in the white space overhead of the racks. And then it went to 800. And then we had the request for 1200, and it continually climbed. But since that 1200 request, we have since seen it jump to 2500 and 3200 amp bus duct, high power bus duct overhead of these racks, which causes a challenge, right? Because in the past, bus duct was always a gray space type piece of equipment. Whereas now it is in the white space, and there's a lot more involved in that, right? You need a lot of more headroom above the racks. You need to be able to cool that busway and cool that power consumption inside that data hall. So it's just been a whole different, total different design change that we've seen inside the data centers. It went from a feeder bus to the busway being directly overhead at these racks.
Yeah, absolutely. And when we talk around the power architecture that we're seeing for AI, the industry so often focuses heavily on hardware and products, but why are services, testing expertise, commissioning becoming increasingly critical in the AI era as well?
Yeah, so they are becoming increasingly more critical because you have so many moving parts now with these AI data centers. The companies that are building these AI data centers themselves are challenged with, let's get it deployed quickly and have a very fast and up and running building as quick as they possibly can. So with that comes the fact that we have a lot of these higher end customers, the enterprise data center customers coming to us and asking us as a company, can you supply the product in a meaningful time period? But also, how can you support this product as well, right? Because they understand that there are some shortages with, skilled labor out there in the industry. I had a talk with the union in Chicago last week, and one of the guys there told me that they had 1,000 union electricians on their payroll. He said, "Nick, I need another 400 to 500." So that was that's a big eye opener, right? That there's just not enough labor there. Starline side of the business as well, from our service team, we have increased our service team over the last 4 years from a personnel standpoint, just over 900%, right? And that comes from the requests of our enterprise customers and the data center customers asking us to not just supply material, but also become a better partner with them, and take further ownership of this. So it's really important for us and our customers that we do get involved, just from a material standpoint, and and start offering the services and our expertise from what their requests are.
Yeah, absolutely. And to that end, why are traditional testing and commissioning approaches no longer sufficient for modern AI data centers?
Yeah, so that's been a challenging one. In the past, we used to come and do testing inside these data centers with air-cooled load banks. We would load up those bus ducts or busways to full load, and it wasn't a problem to have those Avtron load banks inside the data hall. Now, being that a lot of these things are switching from air-cooled to liquid-cooled, they don't have the Cray units or crack units that they used to have to cool the data hall. So it creates some challenges, right? You either need to have a liquid cooled load bank like an LC20, or you need to take your air cooled load banks and move them outdoors, right, away from the data hall, somewhere where they could dissipate that heat. With that said, right, you run into other challenges of longer cable lengths. It's not uncommon for us to see a 300-foot run now versus a 25 or 50-foot in the past. You're propping open doors, keeping doors open inside the data hall, which also creates a challenge of security purposes, right? Somebody needs to man that door and be there at that door 100% of the time during testing. So that the whole approach to commissioning a data hall now in the white space area with a high power bus duct in for AI has drastically changed from what we were commonly seeing in the past.
Yeah, absolutely. And what are the kind of the specific challenges that you have seen emerging when testing these higher power electrical systems in AI environments?
I'd say time and planning. With these high data center, these capacities now that they're asking for, it's a challenge, right? You really need to plan out your testing and commissioning requirements. You have to check breakers upstream. With the introduction to the use of LSI type breakers now, some of these PDUs are dialing down their breaker ratings, and that all needs checked up front. And then from the time standpoint, are we using air cooled, liquid cooled? Liquid cooled obviously has a little bit more setup time with that. You're tapping into the closed loop system, and you're removing those after a while as well too. So there's a lot of things you need to plan for and check up on as well too. And how are you going to refill that system after you've drained a little bit of that liquid out of there? So it's becoming quite the challenge, but nothing that can't be overcome with just a little bit more planning.
Yeah, yeah, makes sense. And of course, we are hearing more and more now about these integrated kind of end-to-end power and cooling systems. So, how are operators adapting commissioning strategies when cooling infrastructure and electrical testing are now far more interconnected?
Yeah. So what I've seen with that is I have seen they've become a little bit more efficient with it, right? Where there are 5 levels of commissioning based off of ASHRAE, right? Where you will do a functional performance testing of your equipment ahead of everything else, right? So everybody does their own functional performance testing. In this situation, we are seeing a lot of the electrical testing happening with the cooling as well too, because it makes sense to hit two birds with one stone here, and do your electrical testing and your cooling all at the same time. From a cost standpoint, it's very efficient, and also from a time standpoint as well too. The downside to it is if something were to happen with the electrical system during that process, or the cooling system during that process, the whole test is shutting down and you have to redo it, right? So there are some challenges and some risks involved with it. It's understanding what those risks are, and knowing how to mitigate those as well moving forward.
Yeah, yeah, absolutely. And to finish us off, looking ahead, how do you see power infrastructure testing and operational services evolving as AI data centers continue to scale in both density and size?
So I see that going to be that, we are constantly going to create new equipment, right? New things are going to be coming out. We're going to become more efficient. One thing I could see happening is, the obviously the electrical systems are going to continue to increase. We need to find a better way to cool those as well too. The old crack and cray units, those are going to have their place. But moving forward, we're going to be looking at a lot more different liquid cooling options as well too, direct to chip, CDUs, internal cooling systems inside the racks, right? So rear door heat exchangers, all of that is presenting new opportunities out there for engineers to really look at this stuff and say, like, what can we do with this, right? We're always going to continue to see the heat dissipation and the heat requirements rising inside these AI data centers. As we move from a 20 or 30 kW rack to a 100 or 150 kW rack, that's going to generate a lot of heat, right? So the challenge moving forward is going to be, how do we continue to scale, in density, right? And, pack as much power as we can into one small data hall, and do it efficiently enough that we can, cool that without having any potential problems moving forward.
Yeah, makes a lot of sense. Well, Nick, thanks so much for joining me.
Yeah.
It's been a pleasure hearing more about what you and the team at Starline are up to. And to learn more about Starline services, please visit www.starlinepower.com/services. But until then, thank you so much to Nick for joining me, and we hope to see you on another DCD talk soon. So thank you very much.
Thanks, Emma. Appreciate it.